lesson, which is chapter 9 in the textbook, we will discuss compressed air and water system. So for compressed air is widely used as a power source for many construction equipments and tools. And of course, recently the hydraulics powers have been replacing the compressed air, but compressed air still being used for many tools, such as you use drill, you have short grit for the concrete. All of that need compressed air. And then the other topic we deal for this lesson is water system. And water system in the construction site can be needed for many areas. First, we need, when you start the project, especially now with the rainy season in Florida, we need dewatering the site so that we do the substructure work, such as the foundation, paving, etc. And then we need the water for concrete mix. We need the water to clean the equipment. We need the water for compactions. We need add water. Remember that when we do the lesson 5, compaction and finishing. So all of that need the water system. So those are the two topics we deal with in today's lessons: compressed air and water system. And that require the knowledge you learn in hydraulics, and also you learn that in fluid mechanics to do for this lesson. So with that, we have 3 learning objectives for today. The first one is categorize the air compressor and water pump used in construction. We calculate the pressure loss in compressed air system and head loss in the water supply system, and use in this case application in construction. And then determine the required capacity for air compressor and water pumps. So that the objective. So let me go overview of the first topic, air compressor. And first we need to find out the air compressor capacity, what capacity should be, and a few review of when we say air, what does that mean? To measure it, first we need what is the baseline, and that defined by standard air. For standard air, it defined as the temperature 68 degree Fahrenheit, so 20 degrees Celsius, at the pressure of 14.7 psi, power per square inch, absolute. A stand for absolute, or in SI unit, 100 kilopascal, kilonewton per meter square at absolute. And the humidity relatively 36%. So those are the standard air. In the real construction site, for example, now imagine that is in Florida, the it not in the this summer, late summer, it's about 4, it's not about 68 degrees Fahrenheit. It can be 85, 90 degrees. Humidity is much higher than 36%, things like that. So it need to be adjustment. So how we do the adjustment, that when we determine the quantity of compressed air, and that go to the process that listed here. First, to determine the volume or the quantity of compressed air, we need to that is the power source for the tool. Basically, we need to know the demand for the air for each individual tool, and normally specified for different tool use, and of course from the manual of the tool. And then with that, we need to adjust for the tool load factor, and that is table 9.2, which I'm going to present next, and or diversity factors. So what does that mean, the tool load factor or diversity factor? Tool load factor. So as you can see, we have on site, we have multiple time of drill, multiple time of the same tool, but most likely you will not use all of them simultaneously, so that we have to adjust for some still on the standby, or in the downsize or downtime, all of that, and that we need to adjust for that. And that go to table 9.2, we'll present in a minute. And then for the whole site, we have variety of tools, and most likely not all of them will be used simultaneously. then we adjust for chop load factor. So basically the two load factor or diversity factor that is the same and that apply for one same tool. For example, 5 driller, 10 driller, most likely will not use at the same time, and that we apply for diversity factor. The chop load factor, we have driller, we have short grit gun, all of that need air compressor, and not all of them will use simultaneously, so we need to adjust for the whole chop load factor, and that across the time of the tool require air compressor. And then throughout the air, as you can see, through the pipe, the hose, etc., the air leakage, we need to allow for the leakage. Typically, if the problem don't given, it's 5 to 10%. And then altitude adjustment also required because the pressure the change for the altitude. So here Florida flat, but if we work in Colorado, some mountain altitude higher, we need to change adjust for that as well. So that the next few slides we will show you all of that table to consider when we determine those table also available in the references for the midterm exam. The first one is the as you can see for different demand for different pneumatic construction equipment, and that yes need to have a compressor at the power source for this equipment, drill and different type of handheld, rifter, gargan or track, and as you can see with different size, the demand for air consumption are changing, range from 55 cubic feet per minute to 1300 cubic feet a minute. Paint sprayer also need the compressor, the demand, and then paving breaker, pumps, submersible, concrete short grit gun, spreader, trench digger, tapper, backfill. So all of that require the air consumption, that quantity. And with that, the table we need to two load factor or also called diversity factor apply for the same time of tool here. So if we apply, for example, here the drill for the handheld, and if on site we have 5 of the handheld drill, then the diversity factor is 1 because most likely sometime all of the 5 driller can be used, so 1. But if you have more than 6, let's see 10, then not most likely not all the 10 handheld drills used at the same time, so we have to adjust, and that the demand it may be reduced about 11%, and that we adjust for diversity factor is 89%. And similarly for depends on the number of tools at the same time, you need to adjust for diversity factor. And then the next one is chop load factor. Chop load factor. Okay. And then we also apply for the altitude, like I say, because the more you go, you need to the pressure are changing. If we are, for example, 6,000 feet altitude or about 1,800 meter height compared to the mean sea level, then we have to adjust money 1.21 for the pressure. So all of that for the demand of the pressure. So all of that it need to be considered for the adjustment. And with that one, let's go back to the problem here. Problem 1, we apply that to determine the quantity of air, compressed air for this application. Determine the rated size of the air compressor required to operate the following tools at an altitude of 6,000 feet. Assume 10% leakage loss and a chop load factor 0.8. So this is for across the time of the equipment, drill, shotgun, paint sprayer, all of that at different time, we need to have a chop load factor. Diversity factor apply for the same time with multiple quantities. So they have what? They have 1, 2, 3, 4, 5 different type of tools that require the compressed air and the rated consumption, cubic feet per meter. So basically this is given. If they don't give that to you, you can be able to get that from this table. Okay, so that's what you have. And then the number of tools on site they give us. Then the question is, what is the rated size of the air compressor required? Basically determine the cubic feet per minute needed. So first we need to do the total consumption with adjustment for diversity factor. Consider the number of same tool used. So for example, Richter drills, we have rated consumption 215. How many of them? 2. Diversity factor, go to the table, 2 load factor, and in this diversity factor, as you can see there, is the for 2, it will be the diversity is 1. Right, so that go to here 1, and then the second one is 8 of them for handheld drill, and each 90 times 8, and the diversity, as you can see, 8, so between 7 and 9 you get 0.94. This is 0.94. Similarly, transdiggers 4, so you have 30 times 4, 1, 6 also 1, 2 also 1 for the diversity factor. So the tool consumptions is 16.27 cubic feet per minute. And then we have to adjust for the chop loss load factor, because not all of these tools, which too many number, will be used simultaneously. So basically we just determine what is the probability of all the tools will be used at once, and from that we'll determine the chop load factor, in this case 80%. So that multiply 0.8, you get 13.02 cubic feet per minute, and that basically the expected consumption, because we say probability related to expected consumption for your site given so many tools in there. And the leakage allowance is 10%, so you see the need additional air due to the leakage, 10%, so 130 cubic feet per minute. So the total consumption, including the expected consumption and the leakage, add them together, 1302, 130, so it will be 1432 cubic feet per minute. And all, when you do all of total compressed air consumption, including leakage, including the diversity factor adjustment for the chop load factors, we then adjust for the altitude. And in this altitude, the project site 6,000 feet. At 6,000 feet, so we go to table of the altitude adjustment here, and that is 6,000 feet. So you have 1.21 for adjustment factor, so that will be on top of everything, 1.21. So we have minimum rated capacity to fulfill the requirement of the equipment for this construction site is total consumptions, including leakage, time the adjustment for the altitude, 1.21, then you have 1,732 cubic feet per minute. So that the first problem, we determine what is the quantity of an air compressor given the number of tools, given the different time of tools. Consider the diversity factor that will be adjusted. Consider the adjustment for the chop load factor, adjustment for the altitude, and that will finally determine the minimum rated capacity. So to have the compressed air, it need to be at least produce 1,733 cubic feet per minute to fulfill